Graphing points and lines. Now we graph points and lines on an XY coordinate system. An XY coordinate system is a plane with X and Y axes used to locate a point or a series of points, also known as a graph or an XY coordinate plane. So in addition to the usual tools that you will need graph paper and you will need a ruler. So let's look at, this is an XY coordinate system, and let's see how it works. Now, going east to west or west to east or sideways or horizontal, whichever way you want to say that, that is the x-axis. This is the x-axis right here. You can see that I've labeled it X. Going up and down or vertically is the y-axis. So this line here that you see is the y-axis, and I've labeled it Y. So on the x-axis there are spaces, and you can see the fifth one I've labeled 5, and that tells you that the value of each one of these spaces is 1. And on the y-axis, I've done the same thing. As you're going up, it's 1, 2, 3, 4, 5, and I've labeled the fifth one 5. Now, if I'm running out of room or something like that, and I need to label that 10 because up here is going to be 20 or something like that, then I would label this one 10 and this one 10, and that would tell me that every time I move a space, it's 2. So it'd be 2, 4, 6, 8, 10. So that is why it's very important to number these. You don't have to number all of them. You don't. I know a lot of people require that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -1, -2, -3, -4, and on like that, up and down also. You don't need to do that. If you've labeled this 5, and on the y-axis you've labeled it 5, 2, then I know what the value of each one of those spaces are. And if I'm on the third space right here, I know that that's 3 because I can, from 5 I can count down 2 and know that that's 3. Let me show you how the axes work. On the x-axis, where they meet is 0. So we're counting 1, 2, 3, 4, 5, and then each space is 6 on out to infinity. But if you go to the left, 1, 2, 3, 4, 5, it's -1, -2, -3, -4, -5, -6, on out to infinity. So, on the x-axis, from the center, if I go to the right, I'm going in a positive direction. If I go to the left, I'm going in a negative direction. And that also works, let's say I start from 5 and I go left. I may go to point number 2, but I'm still going in a negative direction, right? 5 minus 3 would be 2. So I'm still on the positive end of this grid, but I'm going in a negative direction. So just know that on the x-axis, as you're moving left, you're going in a negative direction. As you're moving to the right, you're going in a positive direction. Now the y-axis is as you rise, you're going in a positive direction. As you can see, that's why I've labeled that 5. It's not -5, it's 5. So we're going to be going 1, 2, 3, 4, 5, 6, again, out into infinity. But if I go down, starting from the center, if I go down, it's -1, -2, -3, -4, -5, on to infinity. So, just like the x-axis, I'm going in a positive direction. If I'm going up, I'm going in a negative direction when I'm going down. Okay? So let's take a look at a couple of points that have been drawn on this grid. There, that should be easy to see. In point A, and you're moving on the x-axis just 1 point, just right here. And so the value of that point is 1 as x is concerned. The y value is 1, 2, 3, 4. So that point is labeled 1, 4. Both of those positive. 1, 4. Now let's look at b. On the x-axis, let's count. -1, -2, -3, -4, -5. That's -5 because we're moving left. 1, 2, 3, 4, 5 in the negative direction. So the value of x is -5. What's the value of y? It's not negative. It's 1, 2, 3. So the value of that point, or the location of that point, is -5, 3. Now we're going to write these out so that you can see them later. Now the value of c. Where is c on the x-axis? That's right, it's right here. What is the value of x right here? It's 0. The x value for point C is 0. What's the y value for c? We're going down, -1, -2. So the value or location of c is 0, -2. Okay, like we said, the value of a is 1, 4. Now the first number that you see in parentheses is the x value. The second number you see in parentheses is the y value. So they don't have to tell you what x equals and what y equals. When they put two numbers in parentheses like that, the first one is the value of x, the second one is the value of y. So the value of b, like we stated, was -5, 3. That's x is -5, y is 3. And c is 0, -2. That is to say that the x value is 0 and the y value was -2. Please do not move on until you fully understand what I'm talking about here, because this is the foundation of what we're going to be doing as we go ahead with graphs. Okay, if you look in your book for example number 120, you'll see that we have a series of points that they gave us and they want us to graph them. Okay, so now we know what the points are and we have to put them on our grid. The first one is 3, 2. That is, point A is going to equal 3, 2. 3, of course, is on the x-axis. So we're going to go 1, 2, 3 on the x-axis. And we're going to go up 2, 1, 2. Our next point is -2, 1. So on the x-axis, we're going to go -2, starting from the center, 1, 2, and we're going to go up 1 on the y-axis to about right there. And so C will be our last point. That will be 3, -4. So the 3 is x, going in a positive direction, 1, 2, 3. And -4 is down, 1, 2, 3, 4. -4. Good. And maybe you can see that the value for x on our first point and our third point, that is point A and point C, the value for x was 3 on both of those. So it's just the direction that you go. The first one was going in the direction of y, in a positive direction, and on the y-axis of the third one we're going in a negative direction. So that's how you plant points or plot points on a coordinate system. Okay, now we're going to plot a line, and for a line we need 2 points. Now we're going to put 3 points down, so we need to find the values for x and the values for y. Okay, we picked 3 points, And since x is the most complicated number, it has a coefficient in front of it. We're going to use our guesses for x and our computations for y. Always use 0. 0 is always a good number to use for a guess. Now look at the equation. If x is 0, 2 times 0 is 0, so what would y equal? That's right, it would equal -3. So let's plot another point for x when x equals 2. That would be 2 times 2, that equals 4. 4 minus 3 would be 1. So you can see that when x equals 2, y equals 1. Now when x equals -2, -2 times 2 is -4. -4 and -3 is -7. And if you look at the work that Mr. Wallace did, he used points that were closer together. I like to get my points a little bit farther apart, usually even farther apart than this, and you get a lot more accuracy that way. So keep your points farther apart. So with our calculations, we have 3 points, 0, -3, 2, 1, -2, -7. So let's plot those points on our graph. There is 0, -3. It's a little hard to see because it's right on the line right here. And our next point is 2, 1. Right there, it's a little bit easier to see. We've gone +2 on the x-axis and +1 on the y-axis. And let's plot -2, -7. You should be able to see that. We've gone -2 on the x-axis to the left, and we've gone down -7 on the y-axis. So we have our 3 points, and our points need to line up. If they don't line up, then we don't have a line, and our calculations are incorrect. And they seem to be lined up. Let's use a ruler and see if we can draw a straight line there. There you go, all that lines up, and so we have a good line there. That will be our solution to the equation. But technically we're supposed to put arrows on each side of that line. There you go, and that tells you that the line goes out into infinity in both directions. Now you could have used other numbers, like Mr. Wallace used 1 and -1. And of course you would get different values for y based on the values for x that you choose. But guess what? They're all going to end up on that line. So what is a line? A line is an infinite number of points going in a straight direction. When we say line, that's assumed to be a straight line. Now some of the points that we did not choose could have fractional values, and you don't want to use those. You don't want to use fractions unless you absolutely have to. And later on we're going to have to use fractions, but for right now we don't need to, and we're not going to. But that is our line, and that is the solution to this equation. Let's look at another equation. Our next equation is 2x minus 3y equals 6. So let's plot a couple of points, and of course you already know my favorite points are 0, because when x equals 0, that is the y-intercept, and when y equals 0, that is the x-intercept. X-intercept, the point at which a line crosses the x-axis. Y equals 0. Y-intercept, the point at which a line crosses the y-axis. X equals 0. So let's come up with a value for y when x equals 0. When x equals 0, that would be 2 times 0. Then -3y equals 6. And if you do that calculation in your head, and I suggest that you do not do that calculation in your head, it would be -3 times -2 equals +6. So y is going to equal -2. So the y-intercept is going to be -2, which means our line is going to cross the y-axis at point -2. For our next point, when y equals 0, that would be -3 times 0, that would be 0. Then 2x equals 6. 2 times 3 is 6, so the value for x there would be 3. So the x-intercept is 3, which means our line is going to cross the x-axis at point 3. And like we've discussed before, we only need 2 points to draw a line, but we use a third point as a check. Why don't we do positive 2 for y? So let's look at the equation again. Negative 3 times 2 is negative 6. And if we bring it over to the other side, that will be a positive 6. Positive 6 and positive 6 is 12. So 2x equals 12. And again, please don't do these numbers in your head. Pencil it out. Don't just listen to what I'm saying. Pencil it out and come up with these calculations. So 2x equals 12, which means x equals 6. So let's plot these out. 0, negative 2 is right here on the y-axis. X equals 0, y equals negative 2. So on the x-axis, the x-intercept is 3. And again, that may be a little difficult to see because it's on the line. So x coming out to 3 and a y value of 0. And our last point is going to be x6, y2. And those 3 points seem to line up really well. Let's get a ruler out and check. There's our line, and the points line up perfectly. And don't forget that our line goes out into infinity in both directions, so let's put arrows on that. And that is the solution to our last problem. So in the future chapters, we're going to be plotting lines and calculating slopes and all sorts of things like that. And if you're not real comfortable with what we just did, you need to watch this video again until you fully understand what we're doing. Do the homework and make sure that you fully understand this before we move forward.